Alrighty. Welcome everyone to Ruxmon August. Thanks a lot for all the support. We finally got like a few talks lined up, but please keep sending them so we can fill up the rest of the year and get talks for November and December as well. We still need 4 talks for this year, so if you have something cool that you want to share with people, please submit. And tonight we're gonna have 2 talks. We're starting with Rohit.
That's right.
He's gonna talk about like some hacking satellites and super cool stuff. So please, a hand of applause to the guy and let's go.
Hi everyone, hope you're able to hear me fine. Awesome. Welcome to Ruxmon. It's quite exciting to see such a huge crowd gathered today, although I'd probably attribute that to the next speaker today. I was observing the Ruxmon Discord. There were some chats going on about free pancakes. I hope you guys didn't get the wrong notion from it. But my name is Rohit. I'm here to talk about cybersecurity in space. Quite an exciting topic, but giving you a quick introduction about myself, I recently graduated with a master's in cybersecurity from Monash. I currently teach cybersecurity at Monash, and professionally, I come with about 4 years of work experience working with Deloitte and IBM as a security consultant. I am no industry expert in this topic. It's more of a passion project for me. It's been a little over 2 years since I've been in Australia, and there's one thing that has absolutely stood out for me, which is security events such as this. To get to be in this kind of an environment and to be in a continuous learning environment has been amazing, and that's probably why I'm talking about this topic. I've had the pleasure of attending B-Sides and other similar events across multiple cities in Australia, and that was when I first heard about this topic, and it really piqued my interest. To quickly go over the agenda, the talk would most likely be introductory. The aim of this talk is to get everybody in the audience up to speed on what's happening in the space industry, as well as talk about certain notable incidents. So we're going to start off with why this topic matters, basics of satellite communication to understand how things work, exploring the threat landscape, and taking a deep dive into one of the most popular cybersecurity attack on satellite infrastructure, which is the VIASAT hack of 2022. And I would like to end with giving you some tips on how to set up a home lab if you're interested in this space, as well as some resources to go with. So talking about the importance of cyber, I don't think I need to do a sales pitch on this, but satellites have started to play a very critical part in our lives. Everything to do with communication, navigation, agricultural monitoring, as well as environmental monitoring is all done via satellite. A critical component is also national security. So it is imperative right now and a topic of utmost importance to secure these assets. The growing numbers aren't helping us in any way. Satellites are experiencing exponential growth. Before I show you the numbers, does anybody have an idea how many active satellites are out there right now? Any guesses?
60,000?
60,000, that's very optimistic, but yeah, that's one. Any other guesses? Yeah? He is into the space industry. So, that's pretty good, very close. So just taking a look at the timeline, going back to 2020, we had approximately 5,700 satellites, out of which about 3,300 were active. Jumping 5 years, beating the COVID wave, we have still seen a lot of improvement in numbers. Currently, we are approximately 13,000 satellites in orbit. And this number, of course, 32 of them being Australian owned and operated. This number is set to experience an exponential growth in the next 5 years. 50,000 is just a conservative estimate. It can actually be much greater than that. all driven by mega constellation projects from SpaceX, and Amazon's also entering this space. So there's a lot of potential for research as well as growth in this segment in the next 5 years. Taking a quick look at the rapid growth in the satellite industry in Australia, it's driven by government initiatives as well as a lot of private sector launches. The 5 companies I've mentioned here are just because it's been there in recent limelight for recent launches. Yesterday, there has been a satellite launch I just heard from Peter here. So it's rapidly growing, and there's a lot of scope, I would say, even in Australia with respect to satellite research. So let's probably get to understanding the basics of how satellites work, in case you're not aware. Satellites are largely classified into 3 orbits, the LEO, MEO, and GEO. So LEO stands for the low Earth orbit, MEO is middle Earth orbit, and GEO is the geostationary orbit. Each of these orbits serve a specific purpose and has a specified use case. There is a very cool link called Satellite Tracker 3D, which lets you visualize the satellites we have around us in real time. So let me probably start with removing all filters. And let us probably take a look at the kind of satellites we have over Australia. Starting off with the LEO orbit, or the low Earth orbit. It is already quite congested, as you can see. If I were to zoom in a little on Melbourne. Yeah, as you can probably guess, most of it is going to be Starlink. They move quite quickly. They move at a speed of about 7 kilometers per second. That is faster than the speed of a bullet. So the low Earth orbit primarily takes care of high-speed communication, such as internet as shown by Starlink. The middle Earth orbit is a little far behind. This takes care mostly of use cases of navigation and stuff. The GEO orbit, which is centered across around the equator of the Earth, takes care of TV communication, receiving TV signals, as well as weather monitoring and agricultural monitoring. These are fixated on a particular country and a continent, and is capable of giving you images of the entire continent. So that was just a cool way to visualize the orbits. So how does satellite communications work? It works predominantly using RF waves. We have a ground station that takes care of bulk of the data, basically in terms of ensuring the health of the satellite, as well as sending communication to be relayed back to Earth. So we have a processor on board a satellite which receives these signals, processes it, as well as takes care of relaying it back to the Earth. And what you're seeing down there, or the receiver segment, is also called as user segment, is us, and the endpoints we interact with respect to the receiving the satellite signals. Also, the RF waves are divided into different bands, each band again specifying a certain use case. Starlink predominantly works on the Ka band, which is closest to the Earth, has the most amount of frequency range, and is capable of handling very high speed internet and data. GPS doesn't require that much of data to process, and hence is, as you can see, in the L band, which has the least range of frequency. So, coming to space protocols, I guess this is one of the areas which has the most vulnerability, because there is no standard across the different space agencies there. CCSDS stands for Consultative Committee for Space Data Systems. It's been there since the late 90s, but there has not been any kind of agreement between space agencies until recently, since 2020, I believe, where both NASA as well as ESA, the Europe Space Agency, have agreed to use this as a standard of communication in satellites. This protocol is predominantly based on, or rather developed to ensure reliability as well as error connection. It follows a similar architecture as our OSI layer and has a physical layer, a data link layer, a synchronization layer, and network and other applicable layers. Security is still an afterthought with respect to this protocol. It was not designed to be secure. Security has come as an afterthought with something known as the SDLS, which ensures encryption of every packet. So there is two or three critical protocols in this, which is TM, that stands for telemetry, that takes care of all the information about the positioning of the satellite, the health of the satellite, how is the battery temperatures like and stuff. And TC is where you send across commands, known as telecommands, and the AOS is basically all your bulk data going into the satellite. So without encryption, you could probably only imagine the kind of attacks that could take place on satellite communications. Half of the satellites out there, research says that it is actually communicating in plain text. There is absolutely no layers of encryption. If you wanted to, you could probably go ahead and intercept the connection, but it is absolutely illegal to do that. So this is becoming a topic of, or rather a trending topic, that space is now being weaponized or being used as a new frontier in cyber warfare. A lot of countries are investing into anti-satellite capabilities, as well as working towards satellite-to-satellite collisions, which would create a lot of space debris in our orbits. And there is also a theory surrounding this known as the Kessler syndrome. Basically, it is a theory that says that there exists a tipping point in our LEO orbit. If it is filled with a lot of space debris, it could lead to a cascade of collisions because these particles travel really fast, faster than the speed of a bullet. It could lead to a lot of collisions and render that entire area inoperable because you can't even launch into that area, nor can you navigate an existing satellite around that particular area. Currently, even though we have just 13,000 satellites out there, there are about 38,000 tracked objects greater than 10 centimeter in size, good enough to cause any kind of damage into satellites in our LEO orbit. So let's get to the cyber stuff. How are satellites hacked? Hacked is probably a very strong word, but I've still kept it. It could probably be rephrased to how are satellites compromised. So the space landscape can be largely divided into three segments: the space segment, user segment, as well as the ground segment. In the space segment, we have satellites and just satellites alone talking to each other and stuff. User segment is us, the receivers, and any kind of terminals or endpoints we use to interact with the satellite side of things. Ground segment is what does bulk of the processing. It has to both ensure the satellite is active and the health of the satellite is good, as well as sending in any kind of packets to be relayed. Just looking at this, what do you guys think is the easiest segment to attack or get into? Ground. Spot on. Yeah. We'll probably just see why. Excuse me for a second. So it is the ground segment. Ground segment is typically like securing your corporate. It is only as strong as its weakest IT system, right? So the rest of the segments might require some kind of sophisticated equipment or kind of different attack vector. So coming into the space segment and its threat vectors, it can largely be classified into three. Onboard system exploitation is possible if there exists a vulnerability in the satellite's firmware or software, which can allow for malware injection. Unauthorized entry could eventually lead to your worst case scenario of a full satellite takeover and cause that satellite to satellite collision, which we just spoke about. The biggest problem with this segment is that most satellites still run on legacy software. They cannot be patched in orbit. We can't send people to go fix it in orbit. It's out there, ready to be exploited, sadly. But it does. This particular segment does require a lot of sophisticated equipment, sensitive military equipment, not in the hands of public, because coming to jamming and spoofing, RF-based attacks are possible on satellite, trying to kind of degrade its performance or cause some kind of a denial of service attack. This is an example of a military system that is capable of jamming the uplink of the software. Jamming and spoofing will make a return in the user segment as well, but that would be on the receiving end of things. Here we're talking about the uplink jamming, which would render the satellite inoperable, like in a sense, stop it from giving out any kind of commands back to us. So another interesting threat vector is supply chain risks, both from a hardware as well as software perspective. Hardware, because components of a satellite are sourced from multiple vendors. There has been incidents where chip modifications have led to a persistent backdoor. And supply chain with respect to software is primarily because of the encouragement of nano satellites as well as CubeSats, right? A lot of university students are getting onto it. A lot of private sectors are actually actively trying to push out a satellite by themselves. They end up using a lot of open source libraries, and they're not really aware of the kind of risks that brings in. So that is with respect to the space segment. Coming to the user segment, this is signal jamming and spoofing at a receiver level. Any kind of interference with, or like trying to intercept a satellite signal or jam a satellite signal is strictly illegal. In almost every country in the world. So I wouldn't go into too much detail about saying how this is possible, but I'll leave it at a simple laptop with a $100 investment can disrupt satellite communications in a 5-kilometer radius. So it is that powerful with very little investment. So it's a significant risk, but there is active monitoring for such risks in every city out there. As soon as some kind of a jamming or any kind of intrusion is detected, there would be a military response to counteract it at the moment. So don't try it. With respect to device vulnerabilities, of course, we interact with this data using user terminals. A lot of outdated software or weak firmware have led to a lot of account takeovers as well as breaching the satellite side of the infrastructure, as I would probably show you in an example. Let us actually understand the threat of GPS jamming. In the year 2024 itself, it is estimated that about 40,000 civil aircraft carriers have faced the effects of GPS jamming. In the month of July 2024, the Israeli Air Base was suspected of GPS jamming, which led to the rerouting of several Middle Eastern carriers like Emirates and Qatar Airways. They had to reschedule all their flights for about a period of 24 hours. What happens with an aircraft losing GPS is they cannot rely anymore on the autopilot system. They would have to do a manual override and take over, kind of landing operations by themselves. With respect to safety, even today, autopilot is what is relied upon for landings. until the very last step. So this poses a very significant risk, although I guess no incidents were reported based on it. This is another cool map which kind of shows you real GPS jamming signals that have occurred in the last probably 1 day. This map is from 28th of August. As you can see, the red spots are mainly around Europe and Middle East, probably due to the tensions that's happening in that area. Another area is probably the India-Pakistan border, which is always susceptible to some drone-based attacks. So there is active GPS jamming happening. The reliability of this information is, of course, questionable. Flight Radar as well has their own GPS jamming maps out there. But yeah, this is just in case you wanted to see it. So coming to the user terminal vulnerabilities, Starlink has been quite famous for in the year 2022 when there was a researcher at Black Hat USA who discovered a vulnerability in the user terminal of Starlink. So how Starlink operates is they give you, once you of course subscribe to their services, they give you a user terminal that consists of a satellite dish as well as something like a router. So this particular researcher broke into the terminal with a simple $25 chip. He performed something known as a voltage fault injection attack, and he was able to bypass the protections which was there in the bootloader, basically kind of bypass the secure boot. In case you don't know, secure boot is what verifies if any kind of software update is done officially and stays with, the integrity of any software update is maintained. That is through secure boot. So in response to this, SpaceX started their own bounty program, inviting ethical hackers to test it out. And up to date, there is about 137 vulnerabilities discovered in the user segment side of things. Starlink to date has not reported any cyber attack. Nobody has been able to breach probably the space side of things with respect to Starlink. Another interesting attack was basically hacking Subaru, the car company. This is a very interesting article. Takes a lot of time to read it, but to summarize it, there was this ethical hacker, Sam Curry, who basically used his mother's car to test out if this connected car tech has some kind of vulnerability. And while he was playing around with the Subaru app, he landed up on the Starlink admin portal. So the entire backend of Subaru actually is on Starlink's network. So with that, he was able to get into the Starlink portal, and then he was trying to enumerate employee emails, trying to bypass multi-factor authentication, and he was in. Once he was in, he was able to extract the entire list of locations his mother has visited in the last 1 year. Also, he has stopped with just unlocking his friend's car, but it is clearly mentioned that he could have done this to any car which was in United States, Canada, or Japan, which was using the Subaru connected car app. Yeah.
Just a question. So the terminal was built into the car, was it?
No, so the Subaru connected tech app is based on the Starlink's backend. So he broke through the app and connected to the Starlink's admin panel. So it was not a terminal into the car, it's basically through the app.
Sorry.
Yeah, that's good. So he disclosed this vulnerability. Subaru managed to patch it within 24 hours. So there was actually no notable incidents out of this, but it just goes to show that a very simple access vector could lead to something as drastic as this. Now coming to the ground segment and its threat vectors, here's where you would see your A to Zs of cybersecurity, something which we've all come to know of, network intrusion attacks, weak credentials, insider threats, as well as supply chain and third-party risks. I wouldn't probably get into too much detail. Like I said, consider ground stations to be your typical IT company that you're trying to secure, and basically there's a whole plethora of possibilities to get into it. One such hack which happened in the early 2000s was the ROSAT satellite hack. It was an American German-owned satellite which was deployed for research purposes. A Russian hacker group actually got access to one of the computers in the ground station, pointed the satellite towards the sun, which basically fried all the solar panels on board as well as the onboard processor of the satellite. So this was something that was done in the early 2000s. So what is of more relevance right now? An example of ground segment hack is the VIASAT hack. It is termed a geopolitical cyber attack because it happened in February 2022, exactly 1 hour before Russia's invasion on Ukraine. I'm sure you would have probably heard gist of this particular hack. It basically destroyed about 40,000 modems across Europe, impacted a lot of critical OT sectors in Europe, wind turbines in Germany and stuff. Basically, this led to a loss of internet access for over 10 days in Ukraine, and these modems it was no more a software damage. The modems were actually destroyed, and they had to get new hardware in. So let us try to understand what had happened with the VIASAT hack. So the initial access vector was through a path traversal flaw in the FortiGate VPN. This was actually disclosed with CVE 2018 back in 2018. Even considering it probably came into the public eye with respect to patches and stuff in 2019, this attack was carried out in February of 2022. So they did have about 3 years to have probably patched this. This vulnerability basically allowed for remote unauthenticated attackers to download system files via crafted HTTP request packets. And they were able to access this particular file, which is SSL_VPN_web session, that gave them access to session data as well as credentials in plain text. So once they had these credentials, it was quite easy for them to move about and start the attack. How the attackers pivoted was targeting SkyLogic. It was one segment in the satellite's onboard computer that took care of the Europe operations. They tried to target all gateway and earth stations using this SkyLogic partition. With the harvested credentials, they were able to do some kind of a privilege escalation and gained access to the main management interface of the satellite node. And once they were there, all they had to do was reconnaissance through enumeration scripts, trying to understand what modems are responding back to the satellite and also get a grasp of where these modems are located. So once they had all this information, it was time for the exploit, which was known as acid rain malware. What this is basically a Linux executable targeted at the MIPS architecture, or the microprocessor used in modems, specifically SurfBeam2 modem, which was part of the VIASAT network. What this does is a recursive delete of directories and any kind of flash memory and configurations were completely deleted. This malware ends with a script that forces a reboot. So a reboot onto a device which has no bootloader files basically bricked all these modems, and they were in a constant state of rebooting. The impact of this was all the affected modems were rendered inoperable, and because of the risk of maybe persistence, they were all destroyed. The hardware was completely destroyed. Okay, a lot of talking. So I think that gets me to my end of the talk. I would like to probably give you guys some resources if you're interested in this space. Like I said, I'm no industry expert in this. I really found this topic interesting. So I've tried to see what resources are there. Any kind of satellite hack from our end is actually not possible because of the sensitive nature of this topic. So there exists open source mission control softwares which you can use to kind of build your own home lab. YAMCS is one such open source software, YAMCS, where you can craft the CCSDS packets which I spoke about before. You can kind of use scripts to generate those packets as if it's coming from a real satellite, inspect those packets and try to understand the security behind it. Also, probably, I did this using WSL on my laptop. What would be a great idea would be to put it up on, containerize this, probably put it up on AWS. In a way, you're actually testing the security of a cloud-based ground station. AWS actually has a product called Ground Station as a Service now, which is very exciting to a lot of new startups because it's very cost effective for them. So if you are able to create this software, probably Dockerize it and put it up on cloud, you can actually simulate any kind of a satellite hack by yourself legally. So if I were to inspect the space packet, this is how it would look like in hex view. But with respect to mission control software, you can actually see what those packets I was generating look like. It has the positioning data of a satellite as well as the telemetry. So it's actually mimicking what a mission control sends up to the satellite. So it's probably a playground to. Yes, it's primarily on GitHub. It uses a lot of different plugins as well. So there is one protocol known as the SLE protocol, Space Link Extension. So that was proved to be hacked in a DEF CON talk, and that's probably why I've attributed Vision Space. It's a satellite cybersecurity company that posts a lot of blogs and also a lot of articles on how to use YAMCS. And I would say the most amount of documentation is what I've probably found on Vision Space with respect to using this tool. So they speak about XSS, cross-site scripting, clickjacking, remote code execution. There's also an article on how to crash spacecraft using denial of service vulnerability. Yeah, this is the one I was talking about. Ground control to major threat, hacking the space link extension protocol. I'm trying to simulate this on my own. Like I said, I'm still learning, so hopefully one of you in the audience who's smarter than me is able to kind of simulate what they did and try to understand how this works.
Have there been any cases of like memory corruption bugs in uplinks before?
Yes.
Yeah.
There's,
Can you talk on that a little bit? Like, do you know of any instances?
not in detail. I'll probably have to go back on it, but the simple attacks such as exploiting the buffer with a kind of a denial of service motive is recorded. Probably I don't have the technical detail to go over it right now, but yes, I did.
There's been initialization happening before.
Yeah.
Everything starts being encrypted, maybe key exchange or something. But there's
Exactly.
lots of opportunities for
They do consider cryptography as a cost, right? it's while we think cryptography is essential, cryptography in space protocols it comes at a cost of payload. So a lot of such details are there with respect to how the cryptography key is synchronized across a constellation, and there has been attacks over trying to guess the key, because with that, you get access to the entire constellation of these interconnected satellites.
That's probably a shared secret because they wouldn't bother. They want to reduce the amount of packets exchanged, right?
Exactly. So that was an idea for how you could probably set up your home lab. The other interesting resource I found is obviously YouTube, where VIASAT is a popular Europe-based cyber conference that posts quite regularly about satellite-based hacking, where people from the space industry actually come and demonstrate how critical systems can be compromised, as well as DEF CON talks. All you'd need to do is go into YouTube, say DEF CON space, and you'd see a list of DEF CON talks which have shown some kind of a vulnerability. There's also security frameworks such as NIST and the Australian cyber framework as well, which is constantly being developed. Is there anybody from the cyber industry Australia here? I know Peter is very interested, as he's probably the only one, but a lot of research is going on into building up a proper framework to handle such things. And
The other one is Sparta, which is
Sparta,
similar
yeah.
to the minor attack framework, specifically for space.
Yes, Sparta is another framework which is, like you said, quite similar to MITRE ATT&CK, quite detailed. You'd really get a good understanding and a grasp of the attack vectors there. And of course, the best way for red teamers to learn is probably jump straight into a CTF to test out your skills. So there are a couple of options. VIASAT is a US-based CTF where they actually hacked into a satellite. They were allowed to hack into a satellite rather. Sadly, this event has not seen a return since 2023, but it has a lot of learning modules and a whole course on how they actually built that satellite to be hacked. There is a Canberra space hack 2025. The dates are yet to come. I have registered my interest. Probably keep looking out for this as well. It's quite interesting. And finally, attending local workshops and trainings. I'm quite bummed that I didn't attend the Australian Space Cyber Forum, which happened this year, I think in the month of May in Adelaide. It's going to happen again next year in June. A lot of people from the industry actually come here and share their insights about what's happening in the space industry here. I think Peter has attended that this year. It's quite an interesting event. Yeah, that's about it for my talk. Thank you so much.
Any questions?
Yeah.
That modem hack you were talking about with the Linux malware, I missed, were those modems on the ground or were they in space?
Oh, they were on the ground in Ukraine as well as Europe.
You could walk up and replace them.
You could walk up and disconnect them. But yeah, I think the whole attack was so fast that not many people realized that this was happening. And of course, also the situation was of a war, right? So I'm sure the attention was more towards that.
So the main thing that would have done is just disrupted communications.
Yes, disrupted internet. No credential theft or anything of that sort had happened.
Yeah. The other thing I was going to ask, maybe someone might have a question, but is transport layer security used much in this satellite communication at this point, or is there an equivalent encryption-based communication thing in one of the protocols you were mentioning?
So most of the satellite communication actually happens on the UDP protocol because they want to have it connectionless and quite quickly. But critical commands such as telemetry and telecommands actually use the TCP/IP security, and there is encryption. They use lightweight security protocols as well as AES to kind of encrypt their payloads.
The last thing I was going to say is, you mentioned CubeSats. Melbourne Uni had a space program, or class Melbourne Uni space program, and they launched a CubeSat a number of years ago. I don't know, is anyone here in Melbourne space program by any chance? Yeah.
Yeah, a lot of universities are getting into this and trying to launch their CubeSats.
They were tracking it for a while. I We're very happy about getting it up there. It was from New Zealand, sometime like 2018. Just another example of what you were talking about is just like, because the CubeSats are like, they like reserve like a box slot in some space launch of like 20 or 50 others or whatever.
Yeah, yeah.
Standard size, and they all go up together. So like it is actually quite feasible for
There's actually a whole DEF CON talk about it because CubeSats are actually packed with so many other industries that introduces this whole supply chain risk, right? What if there's one component in the entire launch vehicle which is kind of corrupted? So,
across the universities use C++ code.
thank you. Yeah.
Just one question. I'm just finding it very interesting. I'm going to out my age here. There seems to be, like, I think a synergy in my head of point-to-point microwave links and how they were hijacked in the 80s, like Max Headroom incident in Chicago, how that was hijacked and satellites. And I'm just wondering, in terms of like protection of the uplink, how much power do you need to actually do that kind of stuff?
Protection of uplink with respect to the RF communication. So yes, I think this goes into a concept of electromagnetic waves, right? How it is sent up there is through frequency modulation as well as multiplexing. So maybe I'll answer your question in what's happening with modern satellites right now, like such as Starlink. Starlink has capability to detect if it's being jammed during the downlink, and because it comes with a very smart processor, maybe. So what it does is it tries to change its frequency as well as its multiplexing modes to kind of combat that. With respect to uplink jamming, I guess there's not much you can do. If there's somebody next to you with a much stronger signal, yeah, there's just yeah. So it's probably there is protection in the downlink side of things, but not the uplink.
Cool.
Just a quick one as well. I mean, it's a really old attack, but I know a lot of people used to use satellite TV to watch, like, sports events and things like that. And I remember they were all, I can't remember the specifics, but basically they were all protected with smart cards, and
Yes.
someone managed to like reverse that. Is that? I mean, are people still doing that sort of thing? It's kind of good in a way because I think that actually.
I can tell you 1.2 billion people are doing it. India completely relies on satellite TVs. Yeah.
Has that sort of been addressed more because of those sort of?
I guess not many people care about it because it's a subscription-based model. The authentication actually happens on the smart card end of things, and as long as the operator is happy that, hey, you're paying for my subscription, you don't really worry about how the communication is going through, right? So, yeah.
All right, another hand of applause for Rohit. Thank you, man.
Thank you so much. This was the first time I've spoken in a public event as well, and you guys have been a wonderful audience. Thank you so much for that. See you.
Hi. Now, Lesley? Yeah. Thanks for pancakes. Gonna step up here, start preparing for her presentation. Alrighty. So please, I have a proposal to Lesley and hand over.
Hey y'all. This is my first talk for let's start with that. Yeah, it's not my first talk. It's nice to see you all. I've been to a lot of these events since I moved to Australia, but nobody will talk to me because they don't know me and you all know each other. So I figured
Was it?
it's easy to talk. Then you don't have to say hello to each other.
Froze in the middle, but
I'm Lesley. I've been in Australia for about 6 months now. I'm a fleeing American, if you can't tell from my accent. I work for a company called Dragos, and for the last 17 years or so, I've been doing industrial cybersecurity. Otherwise, digital forensics and incident response, which means I'm one of like 100 people on planet Earth who gets called when a power plant or a ship or a train gets hacked into to figure out what happened. And I have an interesting challenge ahead of me because someday I would like to retire, and I can't hire anybody to do this. It's a really interesting problem because in general, the cybersecurity hiring market for young people right now really sucks. I do a lot of career mentorship and counseling. I review CVs and resumes all over the world, and I see a lot of people who are really struggling to get jobs. And meanwhile, here I am trying to hire people to work on these OT systems doing cybersecurity, and we can't fill positions. We can't find anybody who's willing to do this stuff and understands it at a foundational level enough for us to train them. So I'm going to talk a little bit about what we're facing in this space and how you can get into it if you're interested in working in the operational technology space. Sorry for whoever's watching this stream later. I walk around. Hi. What are we facing here? So first of all, number one, critical infrastructure systems run on industrial controls. When I'm talking about these operational technology systems, and I'll go through some definitions, I'm talking about stuff that like provides clean drinking water and keeps the power on and keeps supply chains and just-in-time logistics, shipping, etc. functioning. When those things go away, it's really, really bad. And secondly, they're increasingly vulnerable to cyber attacks for a multitude of reasons I'm going to talk about. So the first one being they are more connected to stuff than ever before. And I will tell you why that is. It's not just because people suck. There's actually practical reasons for why that is. And they're also becoming more homogenized, meaning they are starting to look more similar. So we've been relying on security by obscurity for a long time in this space, and it is no longer something we can rely on because these systems are coming out of the factory looking the same. And like I mentioned, there's like 100 people on Earth who can do this stuff. And yeah, like 100 people on Earth. And the problem is that we all know each other, and some of us are getting old, and again, some of us would like to retire and move and open a tiki bar someday, and we can't do that if none of you learn how to do this stuff. So let me get you started. So number one, first rule here, Auntie Leslie's first rule. ICS is all over the place. It's places where you don't think it is. You might be used to thinking about it sitting in factories or sitting on trains, but it's all around us in this building right now. It's keeping the lights on. It is providing the AV services. It is keeping the water coming out of the faucets. It is keeping this lovely room climate controlled so it's not miserable in the cold day we have right now. Those are all industrial control systems. We are talking about computers that control kinetic, physical, real-life things in the world around us. So those are also backnet systems. They are backup power. They are lighting. They are generators. They are water cooling. All of those systems are running on industrial control systems, and not necessarily digital ones. Some of them run on gears and human interaction, but they still have control systems that make them function. And in terms of the digital ones, this is getting kind of dire. So what is going wrong here from a cybersecurity perspective? Number one, these things are more connected than they ever used to be. A lot of these systems I'm talking about were developed in an automated way in the 1950s, 1960s. They became digital in like the 1970s through the early 1990s. And then we started connecting them to each other. At first, we were using things like serial protocols. But then, because it's cheap and it's easy and it's accessible to do, we started connecting them via Ethernet and TCP/IP. The second thing that you need to be aware of is the convergence of operational technology and standard enterprise IT technologies. And that is happening because it's cheap and easy to buy a Cisco router and not build your own router. Like, we figured that out. Like, building your own computer and own operating system, yeah, it's very exciting, very fun, and totally cost inefficient. So these companies, these vendors who make industrial stuff decided to start buying everybody's technology. And recently, they've started deploying it to all kinds of different industrial verticals looking pretty much the same. Same IP addresses, same software, same configurations in water, in power, in trains, with differences in the technology that it's actually controlling.
So that makes it more vulnerable. A lot of these industrial devices and stuff that I'm talking about getting hacked and being connected to each other and to the internet and to enterprise networks were designed to be connected by a serial cable. Nobody ever thought about this hackery stuff, so we have to deal with that. And I'm talking about all these security vulnerabilities and how they're really vulnerable, really old, and they oftentimes were never meant to be interconnected at all, but there's a lot of really good practical business and logistical and engineering reasons why they're still vulnerable, and I'll talk about some of those. So sometimes they have to stay vulnerable, so we have to work around that as cybersecurity practitioners. These are really important systems. They cause real-life consequences. We're not talking about compromising a domain controller. We're not talking about popping a box. We're talking about people dying. The cases I respond to are somebody's lost a limb, somebody is dead, a building has burnt down. Sometimes multiple people have been contaminated with something. It's really bad stuff. This has a lot of real-life meaning. I wake up every morning not having any ethical concerns about what I do for a living because I do this stuff, and it saves lives. Unfortunately, bad people know this too. They know that this is a great target. They know that when these things blow up, break, catch on fire, it makes the news, and it makes extortion easier, and it makes it easier to target these environments for espionage, sabotage, other state reasons. And the next question people have for me is what types of cases I respond to. And it kind of falls into three general categories. When I get called out in the middle of the night all over this hemisphere to respond to these industrial cases, the first category is insiders. And it's not always intentional insiders. Yeah, there's people who hate their boss and they want something to explode, and they know how to do that. That's real bad, and I respond to those cases sometimes escorted in by the military or law enforcement. But a lot of times it's yeah, Sue really wanted to watch Netflix in the middle of the night because she's out on an oil platform in the middle of nowhere, so she plugged in an antenna or a modem, a satellite modem, et cetera, just to watch TV, and it caused a really big problem. Or maybe Joe just wanted to update a system and the security controls and isolation weren't letting him do that, so he got out his mobile phone and plugged it into the mine. The second category of stuff, commodity and ransomware attacks. Now, these don't necessarily attack the lower level devices in these industrial networks. When I'm talking about these industrial networks, I'll show you they have lots of different devices in them. Lower level things like PLCs, RTUs, modems, actuators, sensors. Those are typically not running operating systems that are vulnerable to commodity malware. But the higher level systems like the control interfaces that tell you if somebody's gonna die, those oftentimes run on Windows. They oftentimes run on Windows XP embedded, so they're super vulnerable. And you know what happens when you have molten metal in your building and you lose your interface that tells you if it's going to kill somebody? You have to shut down your metal smelting process. That's an obligatory safety thing. So the effect is the same. You still shut down. And finally, there's all the state stuff, the state adversary stuff that has always been a problem. It's always existed. There's always been attempts to sabotage critical societal infrastructure. And there's always been espionage, like industrial espionage, and that just got easier to reach out and touch somebody, to get access to over great vast distances given these internet-connected devices. So it's always been a thing that hasn't changed, but now we can take down a water treatment plant or poison the water or make sewage network. That's a really nasty one from very far away without sending James Bond. And that's a real thing that's happening. A lot of what we see is pre-positioning. It's reconnaissance to be able to do that if there is a military objective or a geopolitical objective. So get in, sit there, be real quiet, and steal all of their access credentials and data so you can attack them later. And we have to deal with this stuff. I mean, like I said, there's 100 of us doing this right now. It's real bad in terms of response and investigations and services for these OT-specific, very finicky environments. And we have to have a plan for dealing with them without thinking about them like enterprise hackery IT stuff. So I'm going to tell you how to do that. We have a lot of bad assumptions, incorrect assumptions about these environments, and I'm going to try to crater some of those for you today. The number one thing that I want you to come out of this room today, when you go to the bar, when you have your beer or your cider or whatever, Remember the word consequences? When you decide to work in this space, your life is suddenly about consequences. Again, it's about the facility shutting down and the trains not running, or the power being off, or the water being contaminated. It's about people dying. I see organizations on horrific days. If you want to get into this space, you can't think about, like, again, popping the domain controller. You can't think about malware, exploits, hacking an individual device. It doesn't matter. What matters is, does somebody die? Real life consequences. I'm going to give you some basic definitions, because we're going to have some conversations about this stuff real quick. So the first one is, when I'm talking about operational technology, that's a word we hackers and IT people use to differentiate the stuff, the industrial stuff, from our enterprise workstations, servers, network infrastructure, et cetera. It's just a differentiating term. You won't see like electrical engineers use it. But when I talk about industrial control systems, I mentioned they're not necessarily digital industrial control systems. We had industrial control systems in the industrial era in the 19th century. They were like gears and pulleys and things, and those still exist. There's still analog ICS. There's things that do simple electronic decisions instead of being modern computers. That all still exists out there. It's just a lot of this stuff has now moved to the digital realm. When I talk about operators, I'm talking about the people who use this stuff every day to like make the water come out of pipes. And when I talk about engineers, I'm talking about the electrical, chemical, process engineers who configure, deploy, and support this equipment. So what's a process? So I talk about processes. It is a system of systems that accomplishes a physical, real-life result. It could be producing crude oil. It could be making tuna cans. It could be getting a train to run. Whatever that process is, it's a system of systems. Let me explain what a system of systems is. So first of all, we need a process loop. A process loop in these environments is either mechanical or physical or digital. Let's talk about the digital form. In a digital process loop, we have a sensor. The sensor checks out what's going on. Then there is a controller that makes some decisions based on that information, and it tells an actuator what to do. That's really confusing. Let me show you what that is. Like, so a sensor could sense a variety of things. It could sense temperature, it could sense motion, it could sense the position of a system. Actuator could be a motor or a pump or a valve. And a controller might be mechanical, but in our cases today, we're talking about computers. We're talking about digital devices. Easy example. Here is a rotating door. Everybody's seen a automatic rotating door, right? Oh, nobody's seen one of those. Okay, oh, cool. All right. So if you haven't seen one of those, you can go next door to the Melbourne University building, and there's one out there. And when you walk in the door, it turns. It's really exciting. I'm from America. We've never seen one of those. It's Australian technology. So if you've ever experienced one of these doors, I think at least one of you has. When you walk in the door, it starts to turn, and when you walk out of it, it stops turning. It's real exciting stuff. This is a simple process loop. There is a sensor. The sensor is sensing your presence in the door. It's usually a motion sensor. Is somebody in the door? And then it's connected to a controller, and the controller says, if there's somebody in the door, I start rotating. And you do that by telling the actuator on the motor to turn the door. Really simple process loop. Of course, things can go wrong in that. If you've ever touched one of them while it's trying to turn, it'll stop suddenly because it also has logic for safety. It knows if it's obstructed, it doesn't want to smack you in the face. That's a lawsuit. So if it's obstructed, it knows to stop turning. It's got logic for that too in the controller, and it issues different commands based on the conditions the sensor sees. What are the things that can fail here? Well, there's really 4 failure states. What are the 4 failure states? The first one is you get in the door and it doesn't turn. We've all seen that happen. There's something wrong with the sensor or the logic. Or the door doesn't stop when you get out. It doesn't know to stop when you leave the door. That's okay. The door just keeps kind of spinning. It loses a lot of warm or cool air that way, but it's not a safety issue. The actuator starts too early or too late. That's an interesting one, right? A sensor starts too early or too late. That's the one where you get smacked in the face because the door doesn't start turning, or you walk into it and it doesn't start turning and you hit your nose. Or in a similar vein, the actuator runs for the long period of time or the short period of time instead of what it was intended in the original logic. Now in a door, when I started using this example, I was like, this is a silly example where nobody ever gets hurt. And then I actually did some research online, and like 17,000 people get hurt by these doors every year. It like makes the news. Not a lot of people die though, so I'm gonna keep using it. But like, these are the 4 failure states for any process loop, anything out there, canning tuna, whatever. You can see what could go wrong in any of these scenarios with like packaging tuna or making trains run. It gets much more severe in like transportation and heavy equipment, things like that. But this is what can always go wrong in any process loop. It's just these 4 things. It's always these 4 things. And these are the things we have to be worried about from a process consequence perspective. It's just these 4 things dependent on the process. And sometimes that involving large trains, trams, molten metal, things like that, airplanes, like it becomes much more serious there. In reality, our process environments, though, like I mentioned, they are systems of systems. Systems of systems are lots of process loops working together to make something happen. Think about our canning tuna. Our canning tuna involves the tuna getting dropped into a can and going down the conveyor belt, and then being sealed, and then being superheated, and then having a label put on it. Those are all individual process loops. And when you put them all together and you synchronize them appropriately, none of those failure states, you get canned tuna. And that's what this looks like. How that works in practicality in our digital environments today is we have something like a DCS, a distributed control system, or a SCADA server, which is coordinating all of these devices to operate at the same timing. SCADA is not ICS. ICS is not SCADA. A SCADA is a device in an industrial control system environment which coordinates a bunch of process loops, sometimes over great distances. Distributed control systems can do that too. It's just a coordinating term. This is not an interchangeable word. There's, in the reality of these process environment, a lot of process loops working together. There's a lot of devices, a lot of coordination in most environments. And these environments become quite complex and quite computer controlled, with lots of different vendors in play and lots of different technologies and protocols. And we illustrate that using something called the Purdue model. The Purdue model is an academic model. Read this academic model. It is not always accurate. It's just like the OSI model. If nobody's ever told you, I have a network engineering degree. The OSI model is not always accurate for every networking situation. That's the same with the Purdue model. But the Purdue model, just like the OSI model, is a good representation of a lot of common things we see. It was made by Purdue University in Indiana back in the early 1990s. And what it shows you here is that there's a layer cake of technologies in these industrial environments to make all of these process loops and technologies work together. At the very bottom, we have very simple analog and digital devices like sensors and relays, really simple devices, oftentimes not connected to modern networking technologies. They talk to very simple ruggedized computers and similar devices like PLCs. These are very simple ruggedized industrial computers that have very simple logic trees and ladder logic on them. But above that, as we move upward, things get more familiar to your hackery brains. And now we have things like operator stations and alert systems and human-machine interfaces that are showing the state of that molten metal. And above that, we see even more familiar servers, things providing engineering workstation capability, analysis and support functions, the domain controllers for the industrial network. At level 3.5, in an ideal world, we have a DMZ that is our breakpoint between our enterprise environment and this industrial sensitive network full of hackable stuff. That is a security control. It's an architectural control. Is it always there? No. Is that firewall sometimes Swiss cheese and full of vulnerabilities and holes? Yes. But in an ideal world, that's there. So you need to understand the Purdue model. This is a representative model, and we talk about these layers to refer to these different technologies. Between each one of those layers in that layer cake, there's different protocols. There are different technologies and vendors in play. We ultimately end up having like 20, 30, 40 different protocols in that layer cake because the different layers talk to one another using different network and Ethernet and serial protocols. You have to think about that too. It's not just all SMB, it's not HTTP, it's not FTP, it's not Telnet. It's like a layer cake of a ton of different industrial protocols, some of which you probably have never seen before. I hope that you're thinking now about where these devices sit in your world. If you are not thinking about them existing in the environments where you work today, I would consider that they oftentimes sit on your network, but in different VLANs, in different subnets that you might not monitor and you might not administer regularly. Again, sometimes they're beneath that DMZ. There's also misconceptions about these environments being air-gapped. They are very, very rarely air-gapped today because people like to remotely access things. But the problem there is that they're also not monitored because we're assuming that they're air-gapped. Yeah, air-gapping is a lie. Let's just leave you with that. I see like 2 really air-gapped environments a year doing this full-time for the last 17 years. It's usually not air-gapped, but you're usually ignoring it because you think it is. These devices perform really important tasks, like with real-life consequences that you might not be taking into account in your incident management frameworks or your risk modeling. You might have not touched them because it's scary, and because they have unfamiliar devices and protocols that your SIM and your IDS don't pick up. And you can't install EDR on lots of the systems. So you might just be ignoring them. And also, there's a human problem. My placard on my desk, given to me by my managers, does not say incident response. It says marriage counselor. Because oftentimes, the engineers and operators hate the cybersecurity people. They hate your laughing. It's true. I have to bring pastries and beer to fix this as a consultant. They have like 10 years, nobody's been to this talk, so they don't know the words, they don't understand the problems, and they're like, here, I'm gonna audit your PLCs, go update them. Yes, they hate you, so bring beer, but otherwise that also means that they might not be telling you what's going on and what problems they have. So here's the realities. Attacks against these systems are on the rise. Adversaries have figured out that these are really vulnerable, really important target, and they are attacking them more often and with much more specificity. They are starting to build toolkits to do it. It's real bad. ICS is often based around legacy, familiar protocols and hardware. So really old stuff. If you're not learning how to use Windows 95 or Windows NT in your curriculum, you might want to get on that if you want to be in this space. You need to know how a hard drive works and a packet, old school. Familiar IT tech is becoming more common though. Like a lot of these vendors, again, have done this convergence thing and now they're using Cisco routers and with all their vulnerabilities, but they're old Cisco routers that are very vulnerable. Same with Citrix, same with Windows, etc. Think about getting back in the TARDIS and going back to like the year 2000. Vendors are starting to deploy the same stuff, which makes it more attackable. Now the same deployments of technologies are going in at water treatment plants as at manufacturing plants. And that means what you can do is build attack toolkits. So it's really bad. Air gapping, again, is a lie. Again, I see like 2 actually air-gapped environments a year. They are in defense and nuclear. If you are not in defense or nuclear, your environment's not air-gapped somewhere. I promise you. I promise you. ICS protocols rarely have any authentication or encryption on purpose because when I hit the big red button on the wall to stop the saw, I need it to stop. And if I've just added a bunch of authentication and encryption to that and one packet is lost, then the person loses their arm. So that's real bad. These protocols have to be super fast, super efficient. They cannot have that overhead, just like the satellite stuff, of a bunch of added encryption. They have to be really simple for a safety reason. They are super sensitive to scanning and exploitation by default. The redundancy and safety controls in these environments come in the holistic system of system, not individual devices. So scanning those devices can absolutely tank them because they're really simple computers. They don't have fully fledged network stacks, but we have other ways to assess them. Operators have different priorities than you. They do not give a crap if the entire infrastructure is infected with Conficker. They care if somebody is going to die, and they are correct about that. ICS is something that you can understand. You can learn this stuff. You can work around these limitations, but you have to think about it in the correct way. So first of all, let me explain a couple of these things before we finish out today. Why is IT and OT converging? Because it saves money. Because it's cheaper to build a simple industrial device based on a common framework and then plug it into a Windows computer than build your own operating system to provide a human-machine interface. We did that back in the 80s. It was really expensive. It meant everybody was running on different technology. Nothing could talk to anything else. And you had to like find the one engineer specialized in that system to do anything. It was really expensive. So yeah, they went out and they bought like Windows computers to be the interface devices, those higher level devices, because it's cheaper. It's easier to train people. Obvious reasons. Why is this stuff interconnected? Because people don't want to go out of their houses. I don't either. Like, we had this thing called a pandemic. I know it wasn't a big deal here. Like, we had something called lockdown. At least one of my jokes is landing here. Yeah, all right. So yeah, we had pandemics, we had lockdowns. But before that, I mean, we have really remote industrial facilities. Some of them are out in the middle of the ocean or in the mountains. I've had to like hitchhike across the ice sheet to get to sites. That's a real story. I've done that. You have to like go take boys at training and get dropped in a NASA swimming pool in an upside down helicopter and swim your way out to go to oil platforms. So like, it's a big deal. Yes, that's real. I'm not lying. I don't lie. It's a thing. Yeah, so it's a big deal getting out to these facilities. So of course, vendors, operators, engineers, administrators want remote access for telemetry, for administration, for being able to service this equipment. I'm seeing now like 8 to 10 remote access methods breaking the Purdue model and that DMZ into a lot of these environments today. Because it's efficient, because we need fast response, we need telemetry, we need remote control, we need real-time control of really, really time-sensitive computer-controlled environments like the smart grid. So we have to add remote access. Air gaps are a lie because of this. Like, everybody wants to tell me their environment is air-gapped, and then I'm like, I act like an idiot because like a lot of the guys who work, the old school engineers, think I'm an idiot because I look like this. So I'm like, oh, okay, I'm dumb Auntie Lesley. Can you tell me what you do if you're sick and you have to service this equipment? What do you do then? And I act really stupid and I hand them a beer and then they're like, oh, well, Joe Bob installed TeamViewer so I can log in from my... So yeah, if you act like an idiot, you find all these interesting facts out about your industrial environment and how it's not actually air gapping. Air gapping is incredibly expensive. Sending human beings out to an oil platform, giving them boys at training, super expensive. Sending them out to mines here, I have to carry a sat phone to do that. It's really remote. It's harsh conditions. It's hard to get there. Like, yeah, you're going to find very few really air-gapped environments, but everybody's going to call them air-gapped. This legacy crap, why are we dealing with this? Why am I doing forensics on Windows NT every week? Because these systems can't come down. Like, they're running the power. They're running the trains. They have like one maintenance outage a year. And beyond just almost never having a maintenance outage, they are tested for years in the factory to run safely and not kill anybody as a comprehensive unit. They are warranted to operate in a certain condition. They were designed to operate in a certain condition. You can't just go removing parts and replacing them. Somebody will die. So when you want to upgrade these systems, it's like a big deal. You go through your vendor, they do a major upgrade, you're down for a week. You have to have redundancies, you have to have it planned out. It's expensive. It takes a long time. These systems have long lifetimes, like 20, 30 years on purpose. And it's a big deal just to replace one computer. It has to be approved by a lot of people. The realities of what I'm dealing with, though, these attacks are on the rise. The state adversaries, the insiders, and the commodity commercial ransomware people have zoned in on these environments because of this. There's targeted attacks. There's people foothold building. They're doing espionage. They're planning for future sabotage, espionage, etc. Ransomware is a huge problem. You lose your control interfaces again, you have to shut down your process, and sometimes you destroy it during an emergency shutdown. Yeah, so we're doing that. So we need you, please, one or two of you in this room, please get interested in OT, because I can't find any candidates to hire, and it's a real big problem. Our community of practice is basically like a Discord. Yeah, it's called Beer ISCAC. We celebrate our alcoholism as we try to cope with these problems. One of the big problems I have in hiring people that I'm going to go talk in Canberra to a bunch of curriculum developers on Monday about is people aren't learning good foundations in computer science. Like cybersecurity degrees oftentimes teach whiz-bang tools. They teach a lot of EDR, like cool theoretical things in cloud computing and quantum computing and things like that. And I need you to know how a hard drive works. I need you to be able to take a packet from a computer made in 1989 and understand what it is. I need you to understand how memory stores stuff on a very simple computer like a PLC. That's what I need. I can teach you the other stuff. I can teach you to use the tools. The tools change all the time. But I need you to understand computer engineering and computer science, period. If your curriculum isn't teaching you that, I don't know what to tell you. Come talk to me. I will try to help you. But you've got to learn computer foundations to do this stuff. I need people who understand how a platter hard drive and SATA work. We need people doing research into this stuff. We need people working in the space for operators, for vendors, for cybersecurity companies, for the government. And there's also research into industrial PLC research, vulnerability research, forensics analysis research. We need more tools for that. There's so much ground to cover. We need people desperately. Again, it's like a few hundred people doing this stuff for massive numbers of systems all over the world. Here's your basic cheat sheet for getting into this stuff. Some key concepts. First of all, it is an overwhelmingly large space. Pick a vertical. If you're just like, I'm going to hack some PLCs, it's not going to get you anywhere. It's like trying to learn to program when you don't have any projects to work on. There's nothing to motivate you to learn how to code or script or whatever. Pick something that's fun. This space is exciting. If you want to learn about trains, learn about trains. If you want to learn about electric power, learn about electric power. If you want to learn about tuna canning, that's my favorite one. If you want to learn about tuna canning, come talk to me after. Making chocolate, whatever. You know, find a space that interests you and focus on a specific niche of cybersecurity and a specific industrial vertical and how it works, that system of systems, how everything fits together. Make sure you've got those great foundations in old crap. Understand consequences come before anything else. If you are thinking about configure and not whether somebody will die or lose a limb, you are doing it wrong. So that means also stop worrying about like, oh my God, I see one PLC on the internet and I can hack it. Yeah, I can hack it too. I'm a forensic analyst. They're real simple computers. Like they're real simple. There's no encryption. You can hack them. You send them a stop command and they stop. What keeps them from exploding is that system of system. It's tons of safety controllers, redundancies, systems checking systems, human operators. That's the real concern. Engineers are a great resource if you know one. If you know somebody who works in an industrial facility, shadow them, ask them questions. They know about this stuff. They get the priorities. Learning about any process will help you learn other processes. If you only have access to learn about like, I don't know, like something you consider boring, maybe packaging tires or something, then learn about that and it will help you learn other things in the future. And be adaptable. This space is, again, it's not a hackery space on the surface. Like you have to think about life safety first. And that means we have to get real creative. It can't just be like, oh, I'm going to install EDR. Oh, I'm going to like patch this computer. Like you might have to think of other mitigations and work with the engineers to come up with a really unusual, abnormal strategy. If you got ICSs, remember that you're in an overarching system of systems. Understand what your worst day ever is. Understand what's actually in your environment and trust but verify. Whatever documents you're getting handed that represent your environment and how it's configured are wrong. They're incorrect. The network maps are wrong. The asset inventories are wrong. These are hard things to maintain, and the operators and engineers aren't super motivated to give you up-to-date ones, so go verify. If they say there's only one way in and out, go verify. If they say there's antivirus running, go verify. If they say there's backups, go check that too. But understand what protocols are in play, what devices, what they actually do, and what safety controls are in place, both physical safety controls like pressure relief valves and digital safety controls like safety controllers, like digital safety controllers. Which ones are computer controlled? Which are vulnerable to hacking? And how are they defending the process from that consequence of concern? And understand how your processes are dependent on one another. If one thing fails, does it cause another part of the system of systems to fail? If you're a student and you want to get into this space, first of all, choose a space to focus on. Don't try to get into OT. Get into like aviation, or get into satellites, get into manufacturing, get into trains, whatever thing you think is cool and you have access to. And a specific area of cybersecurity, whether that's malware research, or vulnerability research, or forensics, or incident response, whatever, threat intelligence. Select a manageable chunk to bite off here. This is a really big space. It's huge. We're talking about like the deep web of technologies here. It's a lot of stuff. There's tons of OSINT out there available to you. Lots of engineers have put things out there on like Scribd and on other document repositories, Pastebin, things like that. So you can learn about this stuff. But also ask questions. Try to job shadow. Try to actually get into an industrial facility legally. Go for a tour. Find out how the process works. Beer is a fun one. We all like beer and distilleries. That's a good industrial process full of PLCs. Yeah, I see a lot of people being like, oh, I'm going to buy a PLC on eBay and hack it. Yeah, you can do that. But again, that's one little piece of that system of systems. Totally disambiguous, detached from the actual process, detached from trains, detached from making beer, whatever. That's not going to get you very far. So it's more important to understand how this all fits together and what can go wrong than, oh, I can hack a PLC, because I promise you I can hack that PLC too after a few beers at the bar here. So yeah, it's very simple technology. If you want to learn more about processes, ask a lot of questions. You will never know as much about chemical engineering as the chemical engineers, and that is okay. They will never know as much about cybersecurity as you do. You have to work together on this problem. Ask a lot of questions and be humble. Learn from them. Learn about what actually matters in these environments and how things are fit together. They have different priorities, and that's okay. That's how you become a trusted advisor. Operators, like I mentioned, they care about like 3 things, like the process functioning safely, nobody dying, and nobody being injured. Like that's the stuff they care about, process, life, and safety. If it's not one of those things, or like high up and close to that, in reality, they are probably not going to care, and that is not a way to approach them. They do not, again, care if every computer is infected with malware, if that malware is not killing anyone. So understand that and prioritize your recommendations accordingly. You taking down every system to clean it up could cause a much worse consequence. Like, I see Configure in environments where it's been there for 10 years. I do not take that environment down. I do not want to be the APT. That would be bad. That would be a career-limiting move. Like, if it's had Configure on it for 10 years and it hasn't caused an impact, we can probably wait for a maintenance outage there without shutting down the whole process and maybe killing somebody, yeah? Finally, there is a white paper out there if you're getting started in building security for these environments. This is where we're at. This is the maturity level of things. There's a white paper out there on the SANS website called the 5 Critical Controls for ICS Cybersecurity. You can go download it for free. And it says this is where people are at right now. Like, these are the basics of cybersecurity we are trying to help operators and engineers with. Number 1, having like a basic plan for incident response in these environments where people might die. Probably good, yeah, but most of them don't. Having secure architecture, so flat networks are maybe bad. Maybe let's try to not have flat networks a little bit more. That's a huge outage, it's a huge cost. It's very, very hard in environments where you might kill somebody by disconnecting the wrong network switch. Yeah, so take some planning, but if we start that, that's good. Network monitoring, it might be good if you get some logs out of these environments, even from like a span port and tap, just so maybe you know if there's a problem. Remote access control, like I mentioned, like everybody's plugged something in at this point. All your vendors have, all your suppliers have, your engineers have, your shadow IT has. Like, you have probably like 10 ways in and out, and you should know about them and maybe get a handle on that. And finally, vulnerability management. It is risk-based vulnerability management, not normal enterprise vulnerability management. Like, again, is it going to kill somebody? What's the likelihood of this vulnerability killing somebody? Not like, oh, it's CVSS 10, like whatever, that's fine in enterprise. But like here, is it going to kill somebody, and is it going to kill somebody tomorrow or 3 weeks from now? Does that mean that we can patch it in 3 weeks or 2.5 weeks? Or do we have to bring down the process and potentially kill somebody to do it right this second? So we call this like now, next, never. Are we going to patch things like immediately with a big process impact? Are we going to wait for the next maintenance outage? Or are we just never going to touch it because it would cause worse consequences to actually patch the thing? External training for you. You can take a picture of this. There is not a lot out there. We need more. There's some free training available from the United States Idaho National Laboratories. Get it while it's still there, says the fleeing American. Yeah, go get that now. Make a copy of it. Paid training, there's quite a bit available from SANS, Dragos, Mandiant, and a number of industrial vendors. But my CEO, Rob Lee, has a free blog on his website right here where he maintains as best as he can what he's jetting between Davos and wealthy people stuff of resources that are freely available to you, including blogs, CTFs, et cetera. That's really good. Thank you for your time. I know everybody wants a beer. It's been fun meeting you all. You can say hi to me now. I live here. I don't know if we've got time for questions. I know we're running a little late, so I know people want to get to the bar. But I'm happy to answer questions if there's time for questions.
Okay, I'll give one question.
Okay, everybody wants to go get beer. I agree. I want to have a beer too.
One? No takers?
There's one up there.
One question, quick.
Oh, and then we go have beer.
Talk about computer science and computer engineering's background.
Yeah.
How relevant would you say electrical engineering is for in this kind of space, or do you get away with more of a surface level and, like you said, rely on talking to lots of engineers?
Yeah, it's a really good question. What degree should you get to be in this stuff? We hire people who were electrical engineers and then wanted to move into cybersecurity and got some training into cybersecurity. And then we get people out of computer science, computer engineering, sometimes cybersecurity degree programs, and we teach them a little bit about electrical engineering. There are big aspects of electrical engineering, mechanical engineering, chemical engineering, physics even in this space, and you will not be an expert at it. So like, don't worry about going to get an electrical engineering degree unless you are like super genius and you want to like double major. A couple classes in it would be useful, but like, the degrees that you really want to be really good at this stuff are like network engineering, computer science, or computer engineering, one of those. Good foundations of how computers work. That stuff doesn't get out of date. The stuff I learned in my network engineering degree in the time when the dinosaurs walked the earth is still pretty applicable. Like we were talking about how everything was going to be IPv6 back then. But yeah, I mean, cybersecurity, just be real careful. Globally, I'm seeing this problem where they aren't teaching like very fundamental computer stuff. The tools change. They have changed many times over my long lifetime since dinosaurs walked the earth. If you want to do this type of stuff, if you want to work legacy, be cautious that you're getting really good fundamentals. Thank you.
That's a wrap. Thanks again for coming to Rux. Remember? Thank you. Remember that like next month, the meetup gonna be in the middle of the month, I guess the second week, because second or third week. The dates in the Discord, because like next month is Sites Canberra, so we're gonna do the meetup 1 week before. Okay? So everyone is going to the pub now. Please buy a beer to Lesley. Thank you her for the amazing talk. And see you guys next month.